Mangroves are extremely important because of the many ecosystem services they provide. For example, because they line the coast, they provide protection against storm erosion, and they also can filter out any pollutants that come from runoff. And they also sequester large amounts of carbon, which is extremely important because of climate change, and they are biodiversity hotspots and provide nurseries for many species.
Drier climates due to climate change events combined with natural events like El Nino has caused massive dieback of mangroves in the Australian Gulf of Carpentaria, which can release many tons of carbon and methane into the atmosphere, even without fire.
These drier environments leave these ecosystems at higher risk of fire, which can make the carbon and methane levels released into the atmosphere even worse.
Our study on the flammability of mangrove species was exploratory. Our hypothesis was that leaf traits would have an effect on the flammability of these mangroves. This field has not been studied at all in terms of mangroves, especially in Queensland, Australia. We modeled our study based on previous studies of plant and leaf flammability. However, this study aims to use that knowledge in a completely new environment with new species.
Our data collection took place in cairns on the mangrove boardwalk, where we collected 5 to 9 samples from 13 different mangrove species. We then took these samples back to the center, where we stripped them of their leaves to get about 40 to 50 grams worth of wet leaves. These leaves were then placed into an oven to dry for about 2 days before we would take them out to burn them.
While burning, we measured 5 traits to cover 2 categories of flammability: mass lost, as well as the time it took for the flames and embers to go out, spoke to the consumability of each individual. The maximum flame temperature, as well as the flame height, spoke to the combustibility of each sample. The ignitability was not counted because the leaves were completely dry and there was no difference. Before each burn, we would note down the humidity, temperature, and wind speed using one of these Kestrel devices. The process of burning the leaves was simple. The direct flame was held to the leaves for a period of 10 seconds, and the IR thermometer that measured the maximum flame temp was held on the leaves for as long as the flames lasted. Maximum flame height was measured by rewatching the footage of the burnt leaves to see how tall the flame got on the ruler. We also timed how long the flames lasted, and then how long the embers lasted before they also went out. Our results are reflected in this heat map. As you can see, certain species burn the least, and other species burn the most. The species that burn the least, such as Cereops and Lumnicera, have small leaves, and the Bruguiera species have larger leaves. But they also have larger leaf volumes as well, so they are only moderately flammable. Vitex has medium-sized leaves, but the leaves are very thin, which is why it burns so well, despite not being the largest leaf.
Over the course of the study, we've collected 84 different samples and processed about 1,000 leaves. Our results have shown us that leaf area and leaf volume are the only leaf traits that have had a significant effect on plant flammability. There have been studies on how leaf traits affect flammability, and that they found that larger leaves tend to burn more than smaller leaves do, and this is reflected in our leaf area having a positive correlation with our flammability traits, meaning that our larger leaves burn more than our smaller leaves.
With this research, we hope that we can provide land managers or people restoring vegetation with knowledge about mangrove flammability so that they can apply the mangrove restoration efforts. For example, if there's a species that is less flammable than other species, we could use that species as to provide a barrier between fire adapted and less fire adapted areas so that fire doesn't spread and damage like the restoration efforts. And also it provides some kind of inbuilt resilience to restoration efforts. For example, if a previously wetter environment becomes drier and experiences a lot of fire, we can plant species there as part of reseeding efforts that we know will be more resilient to fire.
There are limitations that come with just looking at leaf flammability of mangroves, and perhaps for future studies, people can study branch flammability as well and compare it with leaf flammability as well to get a more comprehensive analysis about mangrove flammability as a whole, which would allow us to apply this knowledge more accurately to any restoration efforts involving mangroves and protecting them from fires.
Thanks for watching!